So when you're looking at equations, I want you to think about both of these sides being equal. And if I were to draw a visual here, on the left side I have an x, and on the right, I also have 10 units, we'll call them. So I could draw 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then that is equal to, on the other side, we have no x's, we just have 18 units. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And if you have scales and they're balanced, you are allowed to take the same thing off of each side. So if I have a, I'm actually going to use my eraser for this, or no, I'm going to cross them out as I go. So if I have an x on the left side, but I don't have any x's on the right, I can't take away any x's. But I do have this one unit right here I'm going to cross off on each side. And I have another one that I can cross off, and another one. And I can only cross them off because they are on each side of the equation. And I'm going to keep going. And I cannot cross off any more of the single units because there are no more left on the left side. So what am I left with? I have an x on the left side, and I have 1, 2, 3, 4, 5, 6, 7, 8 on the right side. And therefore, x equals 8 is the answer to this problem. Now, I don't expect you to always draw out the problem visually, because sometimes you're going to have negative and positive numbers, and that might be a little confusing. And sometimes you'll have extremely large numbers and you don't want to have to draw. Even 18 was a little bit too much for me to draw. But so I'm going to show you how we're going to solve these using algebra. So if you have x plus 10 equals 18, you're going to draw a line down the center of the equation, and you are going to look at the variable and say, what are they doing to this variable right here? They have an x, and what are they doing to it? They are adding 10. And what's the opposite of adding 10? Subtracting 10. And whatever you do to one side, you're going to do to the other. And that is going to create a zero pair here. And so I'm left with only an x on this side, and 18 minus 10 is 8. Which is exactly what we got when we drew this problem out visually. X plus 2 equals 5. I'm looking over at the x, and they are adding 2 to both sides, so I'm going to subtract 2 from both sides. This is going to create a zero pair here, leaving me with x equals 5 minus 2 is 3. X equals 3 is the answer. And if I had written this problem out with the visuals, I have an x and 2 on this side, and I had 5 on this side. And when I began to cross these out, I am left with x on one side and 3 on the other. X equals 3. All right, so now we have x 10 equals 8. So if I were to draw the line down the center, and I want to first represent this problem visually. So on this side I have an x, and then I have 10 negatives. And on the right side, I have 8 positives. And it makes a big difference whether they are positive or negative. So that's why I drew the different symbols. So I can take things away from both sides if I have them on each side. However, if you're looking at this picture, hopefully you're noticing there's nothing on that is on the left side that's on the right side. On the left side, I only have an X and a bunch of negatives, and on the right side, I only have some positives. So how are you going to take something from both sides if they're not there? And the answer is you're not. You're allowed to take something from both sides, or you're allowed to add the same thing to both sides. So picture the scales. I can place 10 pounds on one side and 10 pounds on the other if I wanted to, and it would still be even, right? So let me first think about what is going to get rid of these 10 negatives. What gets rid of a negative? Well, a positive gets rid of a negative. So I'm actually going to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 positives to that side. And if I add 10 positives to that side, I must add 10 positives to this side. I gotta keep it balanced. And the reason I'm adding those positives is because a positive time and a negative together, not times, but a positive plus a negative becomes a 0 pair. It's like taking one step forward and one step back. And now all I have left on one side is X, and on the other side I'm left with 18 positives. So X equals 18 would be the answer to this equation. Now, if you weren't going to do it visually, using algebra, you would look at the X and say, what are they doing to the X? They are subtracting 10. Therefore, I'm going to do the inverse of subtracting, which is adding 10 to both sides. And this is going to give me a 0 pair here, and I'm left with an X on this side, and 8 plus 10 is 18. So it's much quicker than drawing all those positives and negatives. However, I wanted you to see that that method also works with positives and negatives. X minus 3 equals 12. I'm going to draw that river down the center or the line. You look at the X. What are they doing to the X? They are subtracting 3. What am I going to do? I'm going to do the opposite and add 3 to both sides. This becomes a 0 pair, and X equals 12 plus 3 is 15. X equals 15 is our answer. X minus 4 equals 6. We're going to draw the river and ask ourselves, what are they doing to the X? They are subtracting 4, therefore I will add 4 to both sides. My negative 4 and positive 4 become a 0 pair. I'm left with X on this side, and 6 plus 4 is 10. X equals 10 is my answer. b divided by 2 equals 5. And I'm actually going to rewrite this problem. B divided by 2 equals 5, like that. The fraction is telling us that they are dividing the b by 2, and the opposite of division is multiplication. So we are going to multiply both sides by 2. Forgot to draw my line there. These 2's right here are going to cancel out. 2 divided by 2 is just 1, but we don't write 1b, we just write b. And 5 times 2 is 10. And that makes sense because this answer that we get should be able to be plugged into this original equation. 10 divided by 2 equals 5. So that's what the answer, that's what the solution means, is we can plug it in for the variable and it will give us a true statement. So the answer is 10. B equals 16. Draw the river. When you see a variable and a coefficient, a number and a letter written right next to each other, it means that they are being multiplied. This actually is saying 2 times what number is equal to 16. So if you think of it like that, 2 times what number would have to go in there to equal 16. It might be easier to think of it that way. I'm sure you already think of the answer, but the algebraic way that we do it is we ask ourselves, what are they doing to the b? They're multiplying by 2. The opposite of multiplying by 2 is dividing by 2. And when you do that, 2 divided by 2 is 1. 1b equals 16 divided by 2 is 8. So the answer is b equals 8. And if you wanted a visual of that one, you could 2b equals 16. You could think of, on this side I have 2 b's, and on this side I have 16 ones. 2, 4, 6, 8, 10, 12, 14, 16. And so if I were to cut each side in half, what would be in those groups? Well, we would be left with b equals 1, 2, 3, 4, 5, 6, 7, 8. b equals 8 would be the answer. Again, visually, however you need to do these problems is fine. I just need you to work it out any way you can. Negative 3b equals 18. So what are they doing to the b? They are multiplying by 3. A lot of my students get confused here and they see this negative and they think, oh, the opposite of a negative 3 is a positive 3. So they add 3 to both sides. However, we're not just doing the opposite of the coefficient here. We're not just focused on the opposite of that number. We're focused on the opposite of what that number is doing to the variable, to the b. So what is, when they write negative 3b, what are they doing? They are multiplying b and negative 3. So if they're multiplying by negative 3, we are going to divide both sides by negative 3. Your whole goal is to get the b by itself. What is going to give me a b right here? Negative 3 divided by negative 3. So the b equals, and then a positive times a negative is a negative, and 18 divided by 3 is 6. B equals -6 is the answer to this problem. B divided by 3 equals -4. So I'm going to rewrite this. B divided by 3 equals -4. I'm going to draw the river here. What are they doing to the B? They are dividing by 3. Therefore, I'm going to multiply both sides by 3. The 3 divided by 3 here cancels out. I'm left with 1b equals positive times a negative is a negative, and 4 times 3 is 12. B equals -12. And if you think about what this answer means, if I plug in this answer for B right here, we're saying that -12 divided by 3 equals -4. Visually, if I were to write out a bunch of negatives, 12 negatives, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then this is saying divided by 3. So if I put these 12 negatives into 3 groups, 1, 2, 3, what is in each group? Well, there are 4 negatives in each group, which is what the problem originally said. -12 divided by 3 equals -4. So that answer was -12.